In this problem, we have a roller coaster. And the lab is also going to be a roller coaster. So roller coasters, sometimes you're at high points on the roller coaster, sometimes you're at low points. And in this problem, the roller coaster is moving from a position that's 5 meters above the ground to a position 20 meters above the ground. So I know there's going to be a change in potential energy. Now I can use 5 and 20, or if I want to eliminate my original potential energy, I'll call 5 ground level. So I'll call that 0. That means everything for heights now are taken from 5 meters above the ground, not from ground level. Just makes it so I have less things in it. Also notice that there's 2 works here. Friction is doing negative work, and the chain mechanism is doing positive work. So I've got, this is the amount of negative work that's being done in the time to go from 5 meters to 20 meters. And that's, so I've got friction and I've got that. I can just put them together because that's my net work. So my net work, I don't really have to write them as 2 separate works. I'll just write them as one net amount of work. So my equation is KO plus UO plus work equals KF plus UF. Now this problem is not asking me for the original kinetic energy or the final kinetic energy. It's asking me for the change in kinetic energy. Now you might say, well, I can get the change in kinetic energy if I could get those 2 numbers, if I could get KO and KF. But if you look at this problem, there's literally no mention of velocity. I have no idea what's happening with the velocity in this problem. So I'm not going to be able to get the change in kinetic energy by figuring out either the original or the final. What I'm going to do is I'm going to solve for the change in kinetic energy. Remember, delta is the symbol for change. I know that the change in kinetic energy is going to be Kf minus Ko. So what I'm going to do with this equation here is I'm going to rearrange it to get Kf minus Ko. Well, I'm going to do that by, if I move the Ko over to the other side, it'll be minus Ko. And if I move the UF over to this side, it'll be, if it's positive on this side, it'll be negative on that side. So doing all that, I'm going to have UO plus W minus UF. So does everybody follow that? So this right here, the combined KF minus KO, that is my change in kinetic energy. So all I have to do is figure these 3 things out. And since I said that I want this to be ground level, I'm going to call this 0, and this is going to be 15, because that's 15 meters higher than 5. And by doing that, I can make the original potential energy 0. So now I have only 2 things I have to fill out. Now, I also always look to see how are they referring to work. Are they giving me the force and the distance up here? Or are they just giving me the work? They're literally just giving me the work. So I don't have to replace W with FD. But I am going to have to replace this with mg times the final height. So solving, we will have the change in kinetic energy is going to equal the net work. So the net work, we got plus 3 and minus 2. So the net work is going to be plus 1 plus 1.00 times 10 to the 4th joules. That's the net work that's happening here. And then I'm going to subtract mgh. So that's going to be mgh. I suppose I should have had a step here where I showed that. So we know that U is mgh, so I just went right to putting in the parentheses here. I probably should have had a step where I wrote W minus mgh. So maybe I should at least do this. W equals mg times the final height. So I can say that this is where these 3 parentheses came from. So my m is going to go in here, my g is going to go there, and my final height is going to go right there. So plugging in the numbers, the mass of the roller coaster is 375 kilograms. Gravity is 9.8 meters per second squared. And the height is really, I'm putting the change in height, because I went from 5 to 20, so my final height is 15 meters. And if you solve that, I don't know, that could be a positive energy or a negative energy. If my change in kinetic energy is positive, then I know the speed increased in this problem. If my answer comes out to be negative, then I know the speed decreased. So what was the answer for this one? Negative 4.51 times 10 to the what? 4 joules. And that really makes sense to me. It makes sense because I know in the problem, I mean, yeah, there was friction and there was work. So actually, this would be raising the energy, this would be lowering it. But it was going from 5 to 20. So my potential energy was going up. Usually, if the potential energy is going up, the kinetic energy is going down, unless you have a big amount of work that's overcoming that change. So in this case, that means that the final kinetic energy is a smaller number than the original kinetic